Hi, my name is Ashleigh Henning. This is my Lab 3, the black hole. The purpose of this lab is to create an orbit of a planet around the black hole, to find the mass of that said black hole, and then determine the velocity needed to fly a rocket around the black hole after launching off the surface of a planet. In the first part of this lab, the system was the star and the surroundings are everything else. Here is where we were able to determine the mass of the black hole using the facts that the star had only the gravitational force of the black hole acting on it. In part 2, the system was the rocket ship, and we analyzed both the forces of the planet on the rocket as well as the black hole in order to determine the velocity needed to go around the black hole without staying in orbit. The first primary finding is that the mass of the black hole was 1.12 times 10 to the 34 kilograms, and then in the second part of the lab, the velocity of the spaceship needed to leave was negative 3.8 times 10 to the 7 in the x direction, 2.0 times 10 to the 6 in the y direction, and 0 in the x, coming only 1.23 e to the 11 meters away from the black hole. The first fundamental principle was Newton's second law, where here we were able to relate the net force to the momentum. Then we were able to derive an update velocity equation and an update position equation. The second fundamental principle we used was the universal gravitation. Here we were able to relate the masses of two objects and their distance to determine the gravitational force between them. The third fundamental principle we had was using the idea of parallel and perpendicular components to describe the forces of the system. Here, knowing the momentum, we were able to describe the parallel forces as the change of momentum in the direction of momentum, and the perpendicular as the difference between the total forces of the system, in this case just gravitation, as well as the parallel. The initial conditions and constants were the universal gravitation constant, the mass of the star, the time interval between data points, which was 86,400 seconds, which is the time of one day, and it began at time equals 0. And the seed that I used in this situation was my email, ahenning7@godtech.edu. We started by defining the initial velocity, then allowed for the determination of momentum and change of velocity in the change of momentum. Using Newton's second law, a change of momentum was equal to the F-net of the system. Secondly, using the equations from the fundamental principles of parallel and perpendicular motion, these values were derived. The change of momentum was known. The parallel was equal to the magnitude of the change of momentum times the direction of momentum, and the perpendicular was the difference between the net force, in this case again, gravitation, and the parallel component of force. In our third step, the mass of the black hole was determined using the fundamental gravitation equation, the magnitude of momentum, and the distance between the star and the black hole. We were able to conclude that the mass was 1.12 times 10 to the 34 kilograms, and source of errors in this part was with each iteration there was rounding. Additionally, the mass of the black hole was slightly different at each round. The motion of the object can be described in this video. In our second part, in the first part of our second half, we established the initial conditions using the black hole mass from part 1. The initial velocity of the rocket was determined via guess and check, and all other knowns from part 1 were used. Here we were able to first derive all the net forces acting on the system, which was the net forces on the planet as well as the net forces on the ship, and then we were able to look at both the analyzation of the movement of the planet as well as the movement of the ship to be able to determine the trajectories of each of these, to determine if the velocity was fast enough to get out of the system. The rocket was able to get to 1.23 times 10 to the 11 meters away from the black hole, with an initial speed of negative 3.8 times 10 to the 7 in the x direction, 2.0 times 10 to the 6 in the y, and 0 in the x. Source of errors again was after each iteration there was rounding. Additionally, the speed of the rocket was determined through a series of estimations. What does it mean? The net force is the definition of the rate of change of momentum. Thus, the parallel and perpendicular components do not differ. What if we had a goal to have a more circular orbit of our rocket? The rocket did not have enough speed to travel outside of the gravitational force of the black hole, and via the same mechanisms of guess and check, we were able to derive the speed to be approximately negative 1.8 times 10 to the 6 in the x direction and 0.9 times 10 to the 7 in the x. Thank you.